Now, the geometric properties of cross products, I mean, the main reason that you do cross products is for this first one right here. That when you take the cross product of two vectors, you get another vector which is orthogonal to the first two vectors. Take, for example, these vectors that I've drawn down here, right, u and v. And let's say both of these vectors are flat with the board, just like they're drawn right here. If I find the cross product of those two vectors, it has to be perpendicular, orthogonal to both, which means it'll have to come straight out of the board. That's the only way that it's 90 degrees with this and this laying in the surface of the board. You know, I can show you, I think this is a old math textbook of mine. No, sorry, meteorology textbook. And, you know, the reason that we study these things is because they're used in science all the time. You know, if you're going to do things that have vector quantities in them, then you gotta use vector stuff. Right? Here's a cross product right there. Here's a dot product right there. You know, it's not a math textbook. It's a science textbook. So that's why we study it. And the only reason that it's being done in the textbook here is because of that first geometric property. Because we need to know a vector which is perpendicular to two given vectors. The next one, notice that the next one actually is another way to find the angle between two vectors that involves sine, not cosine. But you know, that's pretty complicated compared with the one we've already got. The cosine formula is a lot easier because you're just doing dot product in the numerator. Right? This one is the cross product, and then you got to take the magnitude of it. Right? So I think that's a lot harder than just doing a dot product. Okay, this next one, u cross v equals the zero vector if and only if, that's what IFF means, if u and v are scalar multiples of each other, meaning if they're parallel. I mean, we saw on u cross u, we already know that's a zero vector. This one is telling you that, let's say you had 1, 2, 3 as one vector and 2, 4, 6 as the other. One is a scalar multiple of the other. Now, see what happens when you do the cross product. Right? If I cover up these first two, 2 times 6 minus 3 times 4, 0. Right? If I cover up the middle, 1 times 6 minus 3 times 2, 0. 1 times 4 minus 2 times 2, 0. So as long as one's a multiple of the other, that will always be the case. Right? And which is good to know. And then this last one, the magnitude of the cross product of two vectors is actually the area of a parallelogram. Like if this is u and v and the angle that they make with each other, I mean, you could imagine that if I made another v on the other side here and another u over there, that would be a parallelogram. And in fact, this operation would tell you the area of it. Right? That is a geometric property. Okay, and then back to this one for a second. Okay, again, this if and only if. IFF stands for if and only if, meaning if u cross v equals the zero vector, then the vectors are scalar multiples of each other. And if vectors are scalar multiples of each other, then u cross v equals the zero vector. Okay, it means it goes in both directions. I mean, everything doesn't go in both directions. If you are in Virginia, then you are in the United States. Does that go in the other direction? No, right? Things that go in both directions in math terms get the if and only if. That tells you it works both ways.